The exact moment most basements flood isn't during a normal rainstorm. It's during a severe storm serious enough to knock out the power at the same time. That's not a coincidence. It's the single most predictable, most overlooked failure pattern in home flood protection. The sump pump that's supposed to keep a basement dry runs entirely on grid electricity, and the same storm that floods the yard is often exactly the storm that takes out the power keeping that pump running. There's a specific gap in most homeowners' flood protection that only becomes obvious at the worst possible moment. The assumption that a sump pump will simply be there, working whenever it's needed most. A $20 battery backup closes that gap directly, and by the end of this video, you'll understand exactly why it matters more than almost any other single piece of storm preparation. Most of what's on this channel costs less than $20 and takes less than half an hour to understand. That's the whole premise of the Independence Files. Subscribe if that's worth having on hand. A finished basement that floods typically results in thousands of dollars in damage once flooring, drywall, insulation, and any stored belongings are accounted for. And that's before factoring in the very real risk of mold developing in wall cavities that stayed wet for days before anyone could fully dry them out. Homeowners' insurance policies often treat groundwater flooding differently from other water damage, sometimes requiring separate flood coverage entirely, which means a basement flood can end up only partially covered or not covered at all, depending on the specific policy. Cleanup costs compound quickly once mold enters the picture, since remediation often means removing and replacing drywall well beyond just the visibly wet sections, to reach any hidden moisture that's already worked its way into the wall cavity. A flood caught and stopped within hours looks completely different, cost-wise, from one that sat unnoticed for a day or two during an extended outage. Here's the part that makes this particular risk unusually predictable, once you actually think it through. A standard sump pump, sitting in a pit at the lowest point of a basement, does exactly one job: activate automatically when groundwater rises and pump it back outside before it can rise high enough to flood the basement floor. That system works perfectly, reliably, for years, right up until the exact moment a power outage removes its only source of electricity, which, because of how severe weather works, tends to happen at precisely the moment groundwater is rising fastest and the pump is needed most urgently. So here's the real question worth asking. If the single scenario most likely to cause a basement flood, a severe storm, is also one of the most common causes of a power outage, why would anyone design flood protection that depends entirely on the power staying on during exactly that scenario? Think of it like a fire extinguisher that only works when it's plugged into the wall. Most of the time, that wouldn't matter, because fires don't usually coincide with power outages. But a sump pump's entire purpose is protecting against water during severe weather, and severe weather is one of the most common causes of power loss. It's a safety system whose single point of failure lines up almost perfectly with the exact scenario it exists to protect against. Mechanically, a battery backup sump pump system sits alongside the primary pump, wired to detect when grid power to the primary pump has been lost. When that happens, a secondary pump, powered by a marine or deep cycle battery kept charged during normal operation, automatically takes over, continuing to remove rising water exactly as the primary pump would, for as long as the battery holds a charge. This isn't a new or experimental concept. Commercial and industrial facilities with basements or below-grade equipment rooms have used battery-backed or dual-power pumping systems for decades, specifically because engineers recognized early on that any pump, depending on a single power source, shares a critical vulnerability with whatever might take that power source down. The same redundancy principle used to protect a hospital basement or a data center's below-grade equipment applies directly, just at residential scale, to a home's sump pit. Critical infrastructure engineering has treated single points of failure as a core design flaw for generations, well beyond just water pumping. The same question, what happens if the primary system's power source fails, shapes backup power planning in hospitals, telecommunications, and data centers alike. A residential sump pump lacking that same redundancy isn't a design oversight unique to homes. It's simply the same well-known engineering gap showing up in a context where nobody built the safeguard in by default. What changed to bring this into affordable residential use wasn't a new engineering insight. It's that battery technology and small backup pump systems became cheap enough to make sense for an individual homeowner, rather than being reserved for facilities with enough at stake to justify a much larger, more expensive redundant system. Manufacturers of battery backup sump systems publish runtime specifications, how many gallons per hour the backup pump moves, and how many hours a given battery size sustains that pumping rate. That's a direct, testable engineering specification, the same category of information used to rate any battery-powered pump. Homeowners who've actually had their primary sump pump lose power during a storm, not hypothetically, but during a real outage, report a consistent, sharply divided pattern. Those with a battery backup already in place describe a basement that stayed dry through the entire outage, while those without one describe discovering standing water only once the power came back and someone finally checked the basement, often many hours after the flooding had already happened. Three separate threads pointing the same direction. Decades of industrial dual-power redundancy precedent, direct manufacturer runtime specifications that make expected performance verifiable, and a sharply consistent real-world outcome split between homes with and without a backup in place. That's convergent evidence, not a single anecdotal story. It's worth being precise about what varies here. How long a given battery backup actually lasts depends on the specific pump's flow rate, battery size, and how much water is actually entering the sump pit during a given storm. There's no single universal runtime that applies to every home and every storm. What's consistent is the underlying vulnerability this addresses and the clear difference in outcomes between homes with and without protection against it. So if this redundancy principle is this well established in commercial and industrial settings, why isn't a battery backup standard equipment with every residential sump pump sold? It comes down to how these systems get sold and installed. Sump pumps are frequently installed once, during original construction or a basement finishing project, by a contractor focused on solving the immediate water problem. A backup power source for a scenario that might not happen for years is an easy line item to skip when a budget is already tight and the primary pump technically solves the problem as far as anyone can see at the time. There's a simpler reason underneath that. 2. A sump pump with no backup works completely normally the vast majority of the time. It only reveals its vulnerability during the specific, relatively rare combination of heavy groundwater and a power outage happening simultaneously, which means most homeowners never actually experience the gap until the one time it matters most. As for what this actually involves, a battery backup sump system in the $20 range for a basic add-on unit connects to the existing sump pump setup, drawing from a marine or deep cycle battery that stays charged and ready during normal grid-powered operation. The moment grid power to the primary pump is lost, the backup system activates automatically, requiring no manual intervention at the moment it's actually needed. The mechanism mirrors the same dual-power redundancy logic used in commercial facilities for decades. A monitored primary system handles routine operation, while a secondary, independently powered system stands ready to take over instantly the moment the primary loses its power source. The entire point being that the backup never has to be manually triggered by someone remembering to act during an emergency. Now, back to the core vulnerability from the start of this video. Why storms and outages line up so predictably. Severe weather capable of producing enough rain to seriously test a sump pump is frequently the same weather capable of downing power lines or triggering utility-level outages across a wider area. That correlation isn't guaranteed for every single storm, but it's common enough that treating sump pump power loss as a rare, unrelated coincidence badly underestimates how often the two failures actually happen together. There are honest limitations worth being upfront about here. A battery backup provides temporary coverage, not indefinite protection. Most systems in this class are sized for hours of runtime, not multiple days, which means an outage stretching well beyond that window still eventually leaves a basement without active pumping unless the battery gets recharged or replaced in the meantime. Extremely heavy groundwater inflow can also outpace a backup pump's flow rate even while it's running correctly, particularly on backup units designed for shorter, lighter-duty operation than the primary pump. Checking a backup system's rated gallons per hour against how quickly water typically rises in a specific sump pit is worth doing, rather than assuming any backup automatically matches the primary pump's full capacity. Battery condition and age also directly affect how long a backup actually lasts when it's called into action. A battery that's several years old or hasn't been tested recently may deliver significantly less runtime than its original rating suggests, which makes periodic testing worth doing rather than assuming a battery installed years ago is still performing at full capacity. This isn't a substitute for a properly functioning primary sump pump, and it's not being presented as one. It solves exactly one specific vulnerability: Power loss during the exact conditions most likely to require pumping. Nothing more and nothing less. Which loops back to where this started. The same dual power redundancy principle that protects a basement from flooding during an outage applies just as directly to a home's well water pump. Another piece of essential equipment that stops working the instant grid power does, often at the worst possible time. The storms most likely to flood a basement are often the exact same storms most likely to cut the power keeping it dry. Which means the biggest gap in most homes' flood protection isn't the pump itself. It's what happens to that pump during the one scenario it was built to handle. If you've had a sump pump fail during an outage before, or you're not sure how your own system would hold up, drop it in the comments below. I read all of them, and I'll do my best to help you figure it out.